Hello, in this video I want to show you how to do some molar conversions, which is conversions between moles, a number of particles, and a mass of a substance. So we know about the following three quantities. We know about mass, moles, and particle number. Now moles is really just another way of describing particle number, but in groups. Mass and moles are related by the molar mass of a chemical. And you have to look up the molar mass of the specific chemical involved. It's not like every number of moles has the same mass, right? If you have 1 mole of hydrogen, that's going to have a different mass than 1 mole of oxygen or 1 mole of pennies or apples. Moles and particle numbers are related by the number 6.02 times 10 to the 23rd, or about 602 billion trillion. And these two are actually always the same. So every mole of a substance has exactly this many of it. So to help you understand how to do conversions, I'm going to make a picture. If an arrow points from one thing to another thing, it tells you how to convert between them. So we have mass, moles, and particle number. If I give you some number of grams, or some number of moles, or some number of particles, you should be able to tell me how to take that number and convert it. So take some mass of a substance and tell me how many particles are in it. Or take some number of moles and tell me how many particles are in it or how heavy it is. That's what this is. So if you have some number of moles and you want to know how many particles that is, it's pretty easy. You just multiply by this number, because 1 mole is always going to be this many things. And by the way, a particle could be an atom or a molecule. Anything is a particle. If you have a number of particles and you got to get moles, you do the opposite. So instead of multiplying by 602 billion trillion, you divide by 602 billion trillion. That's how you go from a particle number to a number of moles. If you know how many moles of something you have, and you want to know how heavy it is, you just multiply by the mass of 1 mole. So you multiply by the molar mass to go from moles to mass. And to go the other way, if you have some mass and you want to know how many moles of a substance you have, you do the opposite of multiplying, which is divide. So you divide by the molar mass. Now you cannot directly convert between mass and particle number. There is no easy way to say, I have 4 grams of something, how many atoms are in there? That's not easy to do. You have to do 2 conversion steps. So this green line that I've drawn actually does not exist. This is not a full triangle. If you have some mass of a substance and you want to know how many particles, like atoms or molecules, you have, you actually have to do 2 steps. You have to go through moles. It's kind of like a bridge. You need to divide by the molar mass to get to the number of moles, and then multiply by 602 billion trillion to get to the number of particles. And to go the other way, you do the opposite. So in order to go from a number of particles to a mass, so maybe I have 6 trillion carbon atoms, how heavy is that? You would first go into moles by dividing by 602 billion trillion. Then you would multiply by the molar mass of that substance to get to the mass. So all of those relationships are summarized by the following map. This is what I'm going to use. It's not quite a triangle because there is no way to convert directly from mass to particle number. You have to go through moles. So you should think of it more like 2 islands connected by a bridge. If you have a number of particles, to get to moles, you divide. If you have a number of mass, like some number of grams, to get to moles, you divide. So if you're going into moles, you normally divide. And if you have a number of moles, so I have 4 moles of carbon, how many atoms is that? You're going to multiply. Or if you have 4 moles of carbon, how heavy is that? You're also going to multiply. So going into moles, you normally divide. Going out of moles, you normally multiply. Let me show you how to use it. Example number 1. How many atoms are in 3.4 moles of fluorine? So this can be difficult to answer, but if you have the map, it becomes easier. You need to figure out where you start and where you end, because the direction with the arrow, that tells you what you're supposed to do. So this says, how many atoms are in 3.4 moles of fluorine? I know how many moles I have. And I want to convert that number of moles to a number of atoms. So I start here, because it tells me how many moles I have, and I end here. Because an atom is a particle, I want to count how many particles I have. So this is what you do. You just look. If I start with moles and I go to the particles, the arrow in that direction tells me to multiply by 6.02 times 10 to the 23rd. So that's what I'm going to do. I have 3.4 moles, and I take this number and I multiply it by 6.02 times 10 to the 23rd, because that is what the arrow tells me to do. And if you put that into a calculator, what you will get is 2.05 times 10 to the 24th, and that's the answer. There are 2.05 times 10 to the 24th atoms of fluorine in 3.4 moles. Example number 2. How many moles are in 4.7 times 10 to the 24th molecules of water? So this one is a little bit different, because in this case, they tell me how many molecules I have, and I want to know how many moles that is. So let me look at the map. I start with a number of molecules of water. So I start with a number of particles. And I end at a number of moles because that's what I want to figure out. So to go from particles to moles, you look for the arrow, and this is the arrow you use. It says divide by 6.02 times 10 to the 23rd, and that's what I'm going to do. So basically I just take this number, and I divide it by 6.02 times 10 to the 23rd, and you can put that into a calculator. You will get 7.81, and that's your answer. 7.81 moles of water. Example 3. How many grams would 20 moles of potassium weigh? So in this case, I look at my map. I have to figure out where I start and where I end. It says I have 20 moles. Whatever they give you the number of, that's your starting place, because that's what you want to convert into the other unit. So I start with 20 moles, so I'll start here. And I want to know how many grams that is. So this is the mass, grams. To go from moles to mass, it looks like you multiply by the molar mass. That's what this arrow tells me to do. So I'm going to multiply by the molar mass. So I take 20, I multiply by the molar mass, and I get the answer. But I don't know what the molar mass of potassium is, because it's not the same for every chemical. It depends on the chemical. So if you're going from mass to moles, you're going to have to look something up, either online or on the periodic table. So you can look up the molar mass of potassium. It's on the bottom of the periodic table box, and it looks like it's about 39.098 grams. So that is the molar mass of potassium. And so I take that number, multiply it by 20, because 20 is what the problem tells me, and I get 781.96 grams. So if I have 20 moles of potassium, it's 781.96 grams. Example number 4. How many moles of carbon would you have if you had 65 grams of carbon? So you pull up the map, you've got to figure out where to start. The number that they give me is a number of grams, so that's a mass, this is where I start, and I want to end at moles. So I want to go here. To go from mass to moles, it looks like you divide by the molar mass. That's what this blue arrow is telling me to do. So I'm going to take 65 divided by the molar mass. Now the molar mass is not a number. The molar mass of a particular chemical is a number, but molar mass in general is just a placeholder. So this says molar mass, but it's the molar mass of carbon for this problem. So I have to look that up actually. So what you can do is you can Google it, or you can look it up on the periodic table. You just find carbon. And the molar mass of carbon, it looks like, is 12.011 grams. So I'm going to take that number, plug it in where it says molar mass, and divide. The answer is 5.01. So if I have 65 grams of carbon, I have 5.01 moles of carbon. Example number 5. How many atoms of oxygen would be present in 1,500 grams of oxygen gas? And the fact that it's gas doesn't really matter. What matters is that they tell me how many grams of oxygen I have. So I'm going to start at mass, and I want to know how many atoms of oxygen, so I'm going to end at particles. But that's kind of annoying, because if you start with mass and end at particles, there's no direct way to do that. There's no bridge connecting them, because this map is not actually a triangle. So what I'm going to have to do, in order to start here and end here, I'm going to have to take 2 steps. The first step is I'm going to have to go from mass into moles, and the second step is going to be from moles into particle number. In order to go from mass to moles, you divide by the molar mass. That's what this tells me. And in order to go from moles to particles, I got to multiply by 602 billion trillion. So I do both of these. I divide by the molar mass, and then I multiply by 6.02 times 10 to the 23rd. So I got 1,500 grams. Divide by the molar mass, because that's this first step. Then multiply by 6.02 times 10 to the 23rd for the second step, and then that's the answer. Now this says molar mass, but molar mass isn't a number, remember? The molar mass of a chemical is a number. But molar mass in the abstract isn't really anything. So I have to get the molar mass of oxygen. I look it up. It turns out to be 15.999 grams, so that goes right here. And then once you plug in that number, you can put this into a calculator and get the answer. So 1,500 divided by 15.999 times 6.02 times 10 to the 23rd gives me 5.64 times 10 to the 25. So this is the answer. This is how many atoms of oxygen I have if I have 1,500 grams of oxygen gas. Last example. How many grams of iron would 8.23 times 10 to the 22nd iron atoms weigh? So this is how many iron atoms I have. And an atom is a particle. All these subatomic things, particles, atoms, molecules, they're all going to start with particles because it's a direct count of how many you have. So I'm going to start with a particle number because I know how many atoms I have. That's right here. And I need to know how many grams it is. So I want to end here with the mass. And you might notice that there's no direct connection on this map. I'm going to have to take 2 different steps. I'm I'm going to have to go from particles to moles, and then from moles to mass. So you look up how to do that. To go from particles to moles, this is the arrow that I follow, and I divide by 6.02 times 10 to the 23rd. Then to go from moles to mass, I multiply by the molar mass. This is a map telling me exactly what to do. First, divide by this number. Second, multiply by the molar mass. So let me do that. I divide by 6.02 times 10 to the 23rd. Then I multiply by the molar mass. This is the number that I start with. That's why I have it here. I divide first, then I multiply. And so I need to fill this in, because this right here is not an equation. That's why I put question marks, because this isn't an equation right now. Because molar mass isn't a number. I need to put a number in here. So I have to find iron's molar mass. So let me Google what's the molar mass of iron, or find it on a periodic table. Turns out the molar mass of iron is 55.845 grams, so I will plug that right here where it says molar mass. And once you put that into a calculator, you get your answer, which in this case is 7.63. So 7.63 grams of iron. To summarize, converting between related quantities normally involves multiplying and dividing a bunch of numbers. We're going to be doing this in this unit and the next unit too. Second, there are various techniques to remember what to multiply and divide. We're going to be learning many different ways to remember what to multiply and divide, but ultimately that's all we're doing. So that was it. I hope that was helpful.